Hi, my name is Talia. I'm a staff member at Discovery, and I'm going to help you do your homework today. Okay, so in this class, we do a lot of homework questions that involve the normal distribution. And especially for longer ones, more complicated ones like hypothesis testing or confidence intervals, it's really helpful to use Python to kind of make the process quicker. So there's a library in Python that allows us to import a bunch of functions related to the normal distribution. And the line for that is from scipy.stats import norm. All right. And this just downloads a bunch of functions related to the normal distribution, but the two that we use most often in Discovery are norm.ppf and norm.cdf. And one of our other CAs, Mia, did a wonderful video on norm.ppf, but one of the biggest problems with these functions is that they often get confused with each other because they are kind of inverses of each other. They do opposite things. And it can be kind of confusing to know which one to use and which parameters to use and like which problems to apply them to. So I'm going to make a video highlighting, or I am making a video highlighting the differences between these two functions. So let's start with norm.ppf. So you use norm.ppf when you know an area but not a value that will get you to that area. So to explain this, I'll write out the code and the parameters first. It's norm.ppf and then q, loc, and scale. So these two parameters here are usually irrelevant. By default, you don't have to set them equal to anything because they're just equal to 0 and 1 for standard normal by default. So usually you won't even see these and it'll just be the number, right? But if you want, you can set the mean and the standard deviation to be anything you want. So I'll just kind of write that, like mean and SD. Okay, anyway, say you have a value q. That's an area that you have from negative infinity until a number. And you want to find that number that will give you that area. So for reference, the area under the entire normal curve is 1. So like you know, at 0, the area to the left is 0.5. But there are a lot of different like complicated decimals that end up happening when you're finding values in the normal curve. So in general terms, you'd have an area q here that you know, and then this would be some value x or some z-score, I guess. Let's say z. That will get you that area from negative infinity to z. So the area from negative infinity to z is q, and you're finding the z. So usually that's unknown. And say you have an area value, you want to know what value will get you around 84% of the area to the left. So you do norm.ppf 0.84 as your q value. So this becomes 0.84, and then Python will return around 1 because this is around 1. So again, this means that from negative infinity to 1, you will see 84% of the normal curve's area to the left of 1. And that's how you use norm.ppf. So norm.cdf works in the opposite way. You know your value, but you want to know the area to the left of it. This one I think is a little more intuitive because we deal with cumulative distribution functions pretty often. In other words, just the area that, or the probability that your variable is this value or less, which kind of gives you the area to the left, the area to the left answer. So again, the code to kind of visualize this and get us started is norm.cdf, and then the parameter here is x. But again, if you don't change these parameters here, mean and SD, you don't have to really write x. You can just put a number there. And then the same location and scale parameters that end up being the mean and the standard deviation of whatever distribution you have, with defaults at 0 and 1. What?
It says sale, not scale.
Scale. Anyway, so in this case, you put in a number, x, and it'll give you the unknown area to the left of that number. Again, the area under the whole thing is 1, so if you put in infinity, it would give you 1. But doing the reverse of our earlier example, if you wanted to write norm.cdf and say, I wonder what the area to the left of 1 z-score is, you put in 1, and then that would give you the inverse of the answer before, around 0.84, but more specifically, it'll go a bunch of decimals, 0.8413. And these are the main differences between the functions, right? Known x, unknown area to the left, known area to the left, unknown x. And so one more thing I want to say about CDF is that you can use 1 minus's complements to find the area to the right as well. Because we do know that the area under the whole curve is 1. So say for example we wanted to find the area to the right of 1 instead of the area to the left, we would just do 1 minus norm CDF of 1, right? Because this part covers this, and if this whole thing is 1, we can get this area by doing 1 minus the area here. So that would be 1 minus 0.8413, which is like 16, 0.16 or something like that. Is that right?
About.
Okay, that's about right. And that's the basics of norm.ppf and norm.cdf. Hopefully this clears it up, especially with this one. I feel like this one's not as intuitive as CDF.